So we're looking at it's Vsepr, right? And what you'll need is a piece of clay, and I have 6 toothpicks, but you could use something else. These whole toothpicks are going to represent bonded atoms, and then I've got a bunch of like quarter toothpicks. The quarter toothpicks are going to represent lone pairs of electrons. So, okay, we're going to be able to determine the shape of any molecule when we do this. First thing is steric number. This is something that you need to learn to be able to figure out really quickly. So steric number is the number of electron regions around an atom. So an electron region could be an atom's bonded to it, another atom's bonded to it, there'll be a region there, or a lone pair. Okay, so there are no, this is something, unless you have 2 atoms bonded to a central atom, you're not going to have any bond angles. So it's not going to matter. Right? If you only have 2 points, it's always going to be a straight line. So we need at least 2 bonded atoms for us to care about any of this. And electrons repel each other, spreading out as much as possible in 3 dimensions. This is really important because on your page you're writing things in 2 dimensions. Things don't look in 3 dimensions the way they look on your paper unless you take really good care to try and give a good representation. So this is valence shell electron pair repulsion. Right? Think of the repulsion. So steric number of 2 would be 2 bonded atoms and 0 lone pairs. Well, that would be this. We have 2 bonded atoms. We would just stick these on here. So go ahead. And when you're sticking these on, you're trying to remember these sticks represent electron regions. They repel each other. They have the same negative charge. So they try to get as far away as they can. And that's why this is the farthest that you can get these toothpicks or bonded atoms away from each other. And so if you look at that, the bond angle is 180. Right? And if we describe the shape of this molecule, we would call that linear. So that's what I have here. Shape linear, bond angle 180 degrees. That one's pretty simple. Linear is going to show up again, but let's get rid of this. Next, steric number of 3 with 3 bonded atoms and 0 lone pairs. So okay, I've got the two bonded atoms there. If I stick a third in, right? Okay, that's a start, but we can get these bonded atoms farther apart from each other. So you try it. How far apart can you get them? And all of you who drove a Mercedes to school today, you would recognize this shape, right? So we've got, that's as far apart as you can get these atoms. And you're looking at a bond angle of 120 degrees, right? So you could take a look, you can fiddle with it. You can't get farther than 120 here because then you start decreasing the bond angle on the other side. So when you're getting these apart, you're trying to get them collectively as far apart as you can spread them out. And this is going to be in a plane. So this one, if you drew it on your paper, this one would be arranged as you're drawing it because this is in 2 dimensions. We call this trigonal planar, and the bond angle is 120 degrees. Well, if we had the same steric number, right? Same steric number of 3, all we're doing is taking one of these bonded atoms out and putting in a lone pair of electrons. That's why we want this different size there. It's still doing a similar thing, right? This pair of electrons is repelling this pair of electrons and this pair, right? So we're going to have a similar setup, but when we call this shape something, we don't include the electron pair. So when we look at this and call it something, it's only this that we're looking at, and we end up calling it bent. Really technical. So we got bent. Now, 120 was the bond angle if it was 3 bonded atoms, because the electrons, this pair of electrons kind of acts the same for all 3, right? It's kind of spread out. If we have a lone pair of electrons, the electron density here is greater than the electron density for the bonded atom. So think about it for a minute. These electrons, this pair of shared electrons, can spread out. This lone pair of electrons is more here, right? So the electron density is greater. That means this is going to cause more repulsion, and we're going to end up pinching these together just a little bit. So I wrote up here 118. If you said 120, you'd be okay. But maybe 118 is more accurate. All right, so that's steric number 3. Those are the only two cases for steric number of 3. So if you've got a multiple choice problem and you know that it's steric number 3, you have only 2 choices for shape. It's either trigonal planar or bent. Next one is steric number 4. So we get these as far apart as we can. On your paper, it'll end up looking like a plus, like a 90-degree angle. So this is one you got to be careful of, right? It should not be a 90-degree angle because these things can spread out better than that. So actually the best way you're going to do it, if you take that 90 and you make it a little bit more, and then you take these two and you bring them around, kind of put them in a similar spot. Ends up being like a tripod or something, right? The bond angle is a little bit greater than 90, and you should be able to turn any of these. You should be able to turn these so that you're looking at the atoms, and it should look like a little bit greater than 90 between any 2 atoms. And you just try and see, are there any that are a little bit too big, too small, and you just try and orient it, and you're going to come up with something where the angles are about 109.5. That's a number that you're going to remember. And this shape is called tetrahedral. Right? So if you had a die that was shaped like this, it would be 4-sided. Right? So this is tetrahedral, and bond angle is 109.5. Is everybody getting something like that? Right? So notice you've got these 2 sticking off, and then you just rotate it a little bit, and now you got these. Okay, got 4. One of your angles is like less than 90. That's got to be fixed. You have one like this. One like that. Like just if you just look at it and you just start moving it, shifting it. So check with each other. Like see. I don't know. All right, I'll come back in a minute. Wait, come on. What do you got? Got something?